Welcome. Welcome to module 4. This module is all about programming. In this module, we'll study the concepts of programming, principles of programming, or fundamentals of programming without actually discussing any specific programming language. So these principles of programming are equally applicable to all the languages. See, the different languages are not totally independent of one another. Dissimilar things. They're not totally dissimilar things. So programming languages will have some basic concepts. Those basic concepts we are going to discuss in this module. The first topic is programming methodology. So what is programming methodology? Programming methodology is how you represent the solution to a problem. How do you represent the solution to a problem? We discussed about what is problem, what is the solution, different ways of representing the solution, the language independent ways of representing the solution. So how you represent the solution to a problem? We don't restrict ourselves to the language independent methods. We also going to consider language dependent methods. So programming methodology is how you represent the solution to a problem. And the solution to a problem can be represented at different levels. The solution may be represented in the form of hierarchical chart, indicating the different modules. It may be represented in the form of algorithm, indicating the details of each module, and finally in the form of the program written using some programming language. So it can be represented in hierarchical fashion. Like this. Hierarchical fashion, where each dot actually represents a module. We'll see one example also. In fact, we have seen already the top-down design method. There we discussed about this form of hierarchy. So each dot here, each vertex here represent the module. So the solution can be represented in hierarchical fashion. In fact, we start with this representation. So after that we'll be going with the algorithm. You can use a flowchart, pseudocode also, but generally we'll consider algorithm. So we'll consider the algorithm. So we will take this hierarchical representation of modules. Each module is represented using algorithm. So after representing each module using algorithm, then we can convert it into program. So this is how you represent. So hierarchical chart, algorithm, and then program. So all the three are desirable except for trivial problems. That means too simple. Trivial problems. They are very simple. Maybe you can directly write the program. Modularity. The solution to a problem has to be represented as a collection of logically related modules. So whenever the task you are doing is a complex one, is relatively complex one, not too simple, if it's not trivial, then it will be first represented using hierarchical chart using a collection of logically related modules. Each module represents a specific task or at least similar task. So it should represent only one task or otherwise a collection of tasks but they are similar things. For dividing the solution into problems, we can follow either top-down approach or bottom-up approach. Top-down or bottom-up approach. And modularity intrinsically implies teamwork. Implies teamwork. In what way? It intrinsically implies teamwork? So you have represented different modules in the form of hierarchical fashion. So each module can be given to one team member. So that team member can work on it. Team member can work on those modules. After that, solution can be integrated. Advantages of modularity. So it enables us handling the complexity of the solution easily. So the solution may be complex. So it helps you in handling the complexity. It makes programs more readable. That means you can understand it easily. Others can also understand it easily. So it is easy to follow. Solution is easy to follow. Make solutions debugging easy. So debugging means identifying errors. If any. So make solutions debugging easy. And also make enhancements to the solutions also easy. That means the problem requirements may change. In that case, you will be modifying the solutions. That means you will be improving the solutions. That enhancement can be easily made. The other one, generally considered as very important one, is reuse. We can reuse the modules. In what way you can reuse the modules? Okay. Suppose if there is a program which determines the maximum among two numbers, then every time you need to find out the maximum of two numbers. You can compare them. Okay, but what you can do, if you have a module which returns the maximum of two numbers, then each time it is required, you can call it. That means the same module is called. That is reuse. And it also encourages this teamwork. And teamwork can be done easily. And solution development time is reduced. How the solution development time is reduced? Solution development time is reduced in the sense that because you are dividing into modules, each module is given to a separate team member. Those team members can quickly work on those modules, and then the solution can be integrated. If a single person has to do it, it takes more time. Now you are distributing the work. That's why development time is reduced. These are the advantages. Disadvantages of modularity. So at the implementation level, module invocation involves overhead. The module performs trivial functions. It is better to write the code directly at the place of invocation of the module. So probably at this point it is little difficult to understand. Okay, you have divided the problem solution into modules, and whenever required you are calling those modules. You are assuming that you are using those modules. Using the module means you have to call it. In programming terms we call it as invocation or calling it. Invocation or calling it. This usually results in what is called as overhead. Overhead of storing the return address, parameters, etc. Creating the stack, storing the return address, parameters, etc. That is considered as a overhead. Now at this point of time, it may be difficult for you to understand, but we'll take one analogy. We'll take one analogy. What is that? We'll take one analogy. So if the module performs trivial functions, it's okay. Otherwise, you have to if the module performs trivial functions, it's better to write the code directly. So module invocation involves overhead. Module invocation involves overhead. So what is the analogy? What is the analogy? How do you consider that analogy? Any idea? Suppose you have to do one complex task. Let's not bother about programming. You have to do one complex task. So what you can do on your own. What you can do on your own. The other way is you identify the different tasks to be performed and give the task to different persons. Give each task to different persons. You may perform some tasks also, doesn't matter, but some of the tasks are given to other persons. Now how do you give it? How do you give a task to a person? Okay, performing the task, if consider only perform the task, whether you perform or somebody else performs, it takes approximately same amount of time and effort. Okay, it takes approximately same amount of time and effort to perform the task, to perform that individual task. Now what is the overhead involved here? The overhead involved is, if you want to give a task to somebody else, maybe you have to call that person, get his acceptance, negotiate if there are any money related issues, negotiate with them, and then maybe if raw materials are required, you transfer that raw materials. If that person is not having, you will be giving the material that is required, at least your specifications, what you want exactly, you have to explain it to that person. So you will be transferring that to that person. Okay, that person performs the task. After performing the task, again you have to collect the result back. If it is a product, you have to collect the product back and then check it. So the task, whether you perform or that person performs, it takes same amount of time. But what is the overhead here? Calling that function, getting his acceptance, maybe transferring the materials to him and getting the software or product back. All those things are overhead, isn't it? They are overhead. Similarly, function invocation results in, or module invocation results in what is called as overhead. So if the task to be performed is trivial, simple, then don't use modules. Write directly in the same program or function. You will see same function, the same program or the same module. Okay, we will see in the C programming language. So, but function invocation, function calling or using the service involves some overhead. It's better you try to avoid it. And integrating the solutions of modules is difficult and error prone. So you are combining the solutions. Okay, this person has performed this task, this person has performed this task. So you try to combine them. So sometimes they may not be compatible. Sometimes they may not be compatible. Okay. Sometimes they may not be compatible. So suppose you want to create a wooden piece with a hole, and ball has to be exactly fit into that. If you do on your own, you will be preparing this one, and also you will be preparing the ball, and you will try to insert it. If it doesn't fit correctly, you will try to do it, maybe finish it perfectly, and then will try to keep that ball within that say hole. Now, if you give the same two different persons, one is preparing that wooden container with a hole, the other one with the ball. So, because they are different people, though you give the measurements, definitely there is possibility of incompatibility. That happens even in the case of programming. So, no member of the team has complete knowledge of the entire solution. That is another problem. No member of the team has complete knowledge of the entire solution. Each bothers about only his own solution, his own task, his own module. So, no member of the team will have a complete knowledge. The efficiency of the program decreases. The efficiency of the program decreases again because there is a lot of overhead. So, this function invocation takes more time. Function invocation takes more time. So, if you really need efficiency, you may try to avoid these modules. But definitely again there will be trade-offs, efficiency and readability. So, you have to balance. So, this is just an example. So, main module is there, module 1, module 2. So, like that you have divided. Main module is divided into module 1 and then module 2. Again, module 1 can be further divided like this. Module 1.2 also can be further divided like this. Okay, this is an example of modularity. This is an example of modularity. Modularity. So, hierarchical chart, hierarchical representation. So, the difference between top-down approach and bottom-up approach. Okay, this is the modularity diagram. So, there are two approaches to arrive at this diagram. One is top-down approach, start from this one and go down. The other one is start at the bottom and go up. So, top down and then bottom up. Top down and then bottom up. This is top down, and this is bottom up approach. So, you can use either top down approach or bottom up approach. What is the difference? So, top down approach means moves from general to specific. Bottom up means moves from specific to general. So, more natural way we do it for different tasks. So, it is a more natural way. It's less natural but suitable for some problems. What kind of problems we will see? Suitable for programming using procedure oriented programming. So, top down approach is suitable for programming languages which are procedure oriented like C. What exactly is procedure oriented we will see later. But suitable for programming languages, procedure oriented programming languages like C. This bottom up approach is suitable for programming languages which are object oriented like C++, Java, etc. And top down approach is suitable for program design. Whereas for testing it's better you go with the bottom up approach. Testing means trying to identify the errors. Whether you will give input, you will check whether you are getting the correct output or not, or whether you are getting any errors. For that one, you better go with the bottom up approach. Top down approach, start with bigger problem and divide wherever necessary. Bottom up approach, you are starting at the bottom, so solve smaller problems and degrade the solution. The top down approach is suitable for small and moderate complexity applications or problems. Small and moderate complexity. Whereas is suitable for bottom up approach is suitable for complex problems. So, top down approach results in low interaction between the modules. Bottom up approach results in high interaction between the modules. all team members will have some broad view of the entire problem. In the case of top-down approach, that is one significant advantage. Whereas in the bottom-up approach, some team members may not have proper knowledge of the main problem, because you are not starting at the main problem. So you are restricting yourself to the bottom modules. So you may not have clear idea about the entire solution. Structured programming. Structured programming means whenever you are designing programs, you follow structured programming concepts. Follow structured programming concepts. Follow structured programming concepts. So if you follow structured programming concepts, then program will be clear, program will be more readable. So programming started with what is called as unstructured programming. Programming started with what is called as structured programming. Programming started with what is called as unstructured programming. Programming started with what is called as unstructured programming. So that means you can jump from any point to any point. You can jump from any point to any point. Suppose if this one program flow from top to bottom, then you can jump from one point to another point as you like. Means so you should go in this fashion, but you can jump from this point to this point to maybe this point again, or maybe go to this one again. You may jump to this point, then you may come back. So like this, you can jump from one point to another point in any fashion you like. That results in what is called as unstructured programming. So avoid it and use structured programming. The three concepts are sequencing, selection, and repetition. And another important point to be noted here is the structured programming concepts or sequencing, selection, and repetition are supported by all the programming languages, in some fashion. So these are the general concepts. So always try to use structured programming concepts. Now we are not going to discuss this, what is sequencing, what is selection and repetition. We will do it later. But always use what are called as structured programming concepts. Or in simple terms, use control structures. Use control structures or control statements. So use of them makes the programs more readable, understandable, and less prone to errors. So they are time-tested concepts, and every programming language supports them in different fashions. Identifiers. So identifiers are nothing but the names that you given to different programming constructs, like variables, constants, and functions, etc. With different programming constructs. And identifiers are the names you give to those variables, constants, and functions. So use appropriate names. So if you want to add two numbers, we discussed that you can use AB, and we also discussed that instead of AB, you can use first number, second number. Which one is better? So this conveys more meaning. So use appropriate names. Follow the standard and same conventions to name them. That means while writing first name, etc., you may decide that you will write all small letters, or you may write like this. First per. So if you observe carefully, what I have done here, the first letter of each word is capital. That is convention. So try to follow the same convention. That's all. Be aware of the limitations of the length of the identifiers that are supported by the language. Each language may support different length of the identifiers. So I have to use only that length, but it's not a big issue. Local versus global variables. So variables can be local or global. Local can be accessed within the block or functions in which they are defined. Global variables can be accessed anywhere in the program. Again, this may be a little confusing to you, but the point here is, whenever you are writing a program, you are dividing it into modules. You are dividing into modules. Say one, M2, etc. So keep the data as close as possible. That means if you are manipulating, say, A and B module M1, then try to keep it here. While writing the program itself, keep it there. So otherwise it may be little confusing. So whatever the variables, etc., which you use, keep them as close as possible to the modules or functions which manipulate them. So we'll discuss more about what exactly is local, what is exactly the global. That means global means one which is valid across all the modules. Say M1, M2 are here. If they are valid across the modules, then they are global variables. If they are valid only within one module, then they are called as local variables. Always use local variables. Always use local variables. Always use local variables. That's the preferred method. Okay. Indentation and comments. So use proper indentation. Indentation means writing the programs in orderly fashion. It's try to write the programs so that all the statements begin at the same line necessary. So if you are writing some constructs like loops, etc., we have seen with respect to algorithms for loops. So in that case, all the program statements will start like this, and if for loop starts here, if for loop has some other statements, then indent them appropriately. It's the for loop. Within the for loop, you indent them appropriately. That means where you have to write position, alignment, that is indentation. Use comments wherever necessary, but avoid excessive use of comments. Use comments wherever necessary. Comments means about things. So about that function, what is the function? What that function does, that you try to indicate. So you can write comments in programming, that we'll see later, but wherever necessary, use appropriate comments, but don't try to use them excessively. Simplicity versus efficiency. So in case of clash, always go with the simplicity. Simplicity makes the programs more readable. Efficiency decreases the execution time, so you can execute quickly. That means if you do something repeatedly several times, then bother about efficiency. Otherwise, go with the simplicity. Do code optimization wherever possible, particularly in the loops. So you have to use code optimization. That means you try to look at your code and then try to remove the unnecessary statements, move the statements within the code appropriately. Suppose again similar to the algorithm, suppose you have a for loop. And begin, and then is there somewhere. Okay, end is there. Begin and end. So while writing this code, suppose you have a statement like say, as x. Suppose you have a statement like this: sum equal to sum plus x, and you read the sum. Because we have not discussed programming. It may be little confusing, but I try to keep it as general as possible. So x is some variable. So within the loop you are adding. So this loop will be, let us assume that loop will be executed several times. So but you are reading the value of x outside the loop. Okay, you are reading it outside the loop. Then is it necessary to place it here? So if you read it within the loop, that means will be every time you will be changing the value of x. Reading means you may be interested in giving the same value, or maybe interested in giving different value. Then it is appropriate to write like this: sum equal to sum plus x. Otherwise, instead of writing it in the loop, the sum equal to sum plus x, instead of writing here, you can just write outside the loop. Sum equal to sum plus x. Sum equal to sum plus x. So you can write it outside the loop. So we will get more clarity when we discuss programming. But these concepts are not discussed generally in the programming language related books. You don't find them anywhere. Okay. The general concepts, not that you don't find in any book, but usually programming language books you don't find. Steps in developing a computer program. What are the steps in developing a computer program? You can just note down these things and you can follow it. Take a snapshot. So gather the required information for solving the problem. Interact with the customer. So whatever the information that is required for solving the problem, gather that information by interacting with the customer. So after gathering all the requirements of the problem, write the problem statement. Problem statement means you try to write it in one sentence, something like a definition. It should convey everything. Problem statement. Or otherwise also you can give a detailed description of it. After that, give the specifications of the problem. That means you try to be precise and try to specify exactly what the program should do. Build a prototype of the solution. Okay, you cannot write the total program, so build a prototype of it. Remember, prototype can be a program, or sometimes prototype can be in the form of video also. Let us assume that prototype is in the form of full program. So you write a simple working program, show it to the customer, gather his requirements, refine. So decide the expected outcomes of the solution. So what are the expected outcomes? Because you have to find out whether the solution is correct or not. So decide the expected outcomes of the solution. Generate all possible solutions. So there are a number of solutions. Generate all possible solutions. Generate and prioritize all possible solutions. You can avoid this generate here because it is all there in the statement. So prioritize all possible solutions. So we have some different solutions. So prioritize them. Choose the probable best solution. According to you, what is the best solution? Choose it. Write the algorithm, test the algorithm for correctness. Okay, check whether it is working correctly or not. The algorithm cannot be executed with a computer, so you have to check it manually. For most of the programs which you are going to write in your BTech, you can do manual checking also. Convert the algorithm into program. That means you write the program. So after that, convert it into object code. That means you will be compiling it, and then you run the program, test the program. That means you give some input, get the output, check whether it is the correct output or not. Next, document with all the necessary details. So usually for large programs, you have to document, put everything in the form of a document. So not just your program, your interaction with the customers. What are the customers saying? Who are the customers? Okay, what is the feedback that they have given us? What is the feedback that they have given us, and what questions you asked them? What is the answer to the questions? So like that. And then maintenance. And maintenance is a continuous process. That means you will be doing modifications or enhancements to the code whenever necessary. So you can repeat the steps 9 to 16 for all the other possible solutions. Because here you have chosen the best possible solution. There will be remaining solutions also. So you can repeat these steps, and then after that you can decide which one to use finally. So these are the some of the references. So try to go through these 3 elements of style. So it can be downloaded, as it is MNT pressing, it can be downloaded. So go through this one. The point to be noted here is the references. We will give huge number of references. I will just tell you which ones you have to refer. So these are the references which I have referred, but it doesn't mean you have to go through all these references. It's difficult for you. And if you are really interested, if you trust yourself, you can try to go through these courses by Stanford. And the videos are freely available on YouTube. So you can go through these things: programming methodology, programming abstractions, programming paradigms. In fact, this module is defined by that one. But these can discuss different programming languages, concepts in different programming languages. For that, you require multiple programming languages. Want to discuss multiple programming languages at a time, then you can follow this process. Otherwise, you cannot. Single programming language, we cannot do it. So they do it in the Stanford, but probably we are not Stanford at present. So, but nevertheless, can go through them. I don't say that you don't understand the concept, but you already have some knowledge of programming, then it's better. So wish you a happy day. Thank you for joining.